Hello, my name is Matthew Wallace and I'm a senior consultant with Contino. Today I'm going to be talking about how I'm using the HashiCorp stack to improve and easily deploy my home automation setup. And as we go through, I'll talk also about how we at Contino use this various tools from HashiCorp to support our customers as they migrate to the cloud and to improve their software delivery patterns. So we'll have a look at the home automation dream and where I'd like to be eventually, because I'm not quite there yet. We'll look at why I've chosen HashiCorp for these particular roles. We'll look at the stack that I'm using, we'll look at the results, and then we'll look at how the stack that I'm using can be adopted quite easily in enterprise settings. I started doing home automation about 15 years ago. I've always tried to do it where I can using open source software, from Linux Media Center Edition back in the day through to Home Assistant, which is what I'm using as the brains, if you like, for the home automation now. I've also always been interested in monitoring metrics and observability, including Internet of Things. And so when the opportunity came up to look at how to deploy sensors within my house, how to monitor electricity usage, temperature, humidity, air quality, all of that kind of thing, it seemed like a really good place to sort of marry up my hobbies with the work that I do at Contino around the observability patterns. So before we get too far into this, let's have a look at what we mean by home automation. So there's a few things that I think a good smart home should do. The first is to work with the occupants to make their lives easier. And by this I mean, if the lights dim, if it starts to get dim outside, the lights should come on inside. You shouldn't even need to think about having to press a switch or anything like that. True automation is not having to interact with your house. If it starts to rain, the windows close. If the temperature gets too hot, the windows open again. And all of these kinds of automations make our lives easier. It means we don't have to think about the way in which we live with the environment around us. It just happens. The next thing for me, and this feeds in a lot to the sort of reliability and resiliency and redundancy planning that we do a lot of with our customers at Contino, is that my smart home needs to work even if the internet is down. So if I don't have a connection to the outside world, I should still be able to turn my lights on and off. My heating should still work, that kind of thing. You will have seen recently the houses that are without power for days at a time. You know, I've got minimal battery backup, but it is there for the event of a small power cut. But the idea of not having any heating or cooking facilities or lighting or anything like that for an extended period of time, not because I've lost power, but purely because I don't have an internet connection, isn't a situation that I want to find myself in. A good smart home shouldn't get in the way of guests. We've got kids, we have babysitters over, we have grandparents over, basically people that don't usually live in the house. And so, as a result, with a couple of exceptions, almost all of the lighting in my house is a smart switch rather than a smart bulb. What this gives us is a standard user interface, if you like, that is recognised by everyone that comes to the house. They can turn the lights on, they can turn the lights off, they can adjust the brightness, and they don't have to talk to a voice assistant. And I've got one in the room with me now, so I have to be quite careful about what I say. And they don't have to install an app or anything like that on their phone, which a lot of people just simply don't want to do. And then there is really a need to have at least one thing that makes people go, wow. This kind of is a bit at odds with the first point, because to me a smart home should blend into the background. As I say, it should just be there, ticking away, monitoring the lights, temperature, adjusting the thermostats accordingly, adjusting the heating, closing windows, opening windows, raising blinds, lowering blinds, all of that kind of stuff. But every now and again, you do want something that's just that bit special. And in our house, we've got some LED lighting that reacts to music. So we can have a bit of a disco going on, which is a bit of fun, especially sort of if we have family over, or we've got friends around and we put music on or something like that. So that's the kind of stuff that I look to implement with home automation. So let's have a look at what a perfect morning routine might look like based on those things. And I should probably preempt this by saying I'm not there yet, but I'm getting close to this. So 7 o'clock in the morning, the alarm goes off. And that could be a voice assistant, such as the Amazon Echo or Google Nest or one of the other myriad of options out there. And that triggers a routine within the home automation controller. The home automation controller checks the time. It can look at light levels outside. You could even build it into your Health, Apple Health or Google Fit platform to see what your sleep routine would be like. And then, depending on all of the variables that it checks, depends on what it does next. So it could fade the lights up gradually to give the effect of a sunrise. It could fade in a news bulletin or some music or something like that. It could switch on the kettle or the coffee machine to make sure that the water is boiled and ready waiting for you by the time you get dressed and downstairs. And then as you come down the stairs, it can pick up the movement and it can start to raise the light levels in the rooms as you walk into them. And it could even start, if you've got a car such as a Tesla or one of the other cars that have got the smart internet connectivity in them, you can get it to start the heater, you could get it to warm the heated seats, defrost the windscreens if it's a frosty morning like it was this morning. We're here in the UK, all of that kind of stuff, before you've even left the house. And it can even calculate your commute time, so you know whether you need to leave a little bit earlier or a little bit later. And then as you walk out the house, it can check and see who else is in the house. And maybe even lock the door based on the occupancy sensors that it has. I'll come to smart locks in a minute, but that's an idea of the perfect morning routine that you could go through. So how do you work out what it is you need to do and where your morning routine and all the other routines that you have, how do you work out what they should look like? Well, for me, it's about gathering user stories. And those of you that work in software development or have been involved in the DevOps movement or indeed even SRE these days will be familiar with this concept of a user story. As a customer, I want to check out using PayPal so that I can give all my money over to Amazon for the goods that they provide, something like that. These are distilled user stories on this slide, but it shows you some of the key ones here. So in our house, we've got a mixture of adults, children, and teenagers, which means we need to be able to make sure that only certain people are allowed to access particular content that's out there on the internet. We need access to the services, needs to be as straightforward as possible, and to me that means someone typing Home Assistant into a browser or Octoprint for the 3D printer, not having to remember that it's on 192.168.5.23 or something like that. People who aren't geeks like me tend to struggle to remember IP addresses. So DNS is a must. And not everyone has a mobile device or access to a mobile device. This comes back to the smart switches as well. Our youngest doesn't have a mobile phone, and therefore she doesn't have the app to control the house. She can talk to the Amazon Echo, and 75 to 80% of the time it responds. But it is a challenge that we have. And that kind of brings us on to the next thing about visitors and guests. So this could be anyone. It could be in-laws, grandparents, it could be babysitters, it could be builders, it could be delivery people. And so there's a security risk around here. But also they either won't have access to the apps or they won't want to install an app. They may not necessarily be tech savvy. And they certainly don't need access to the entire network. It's very unlikely that if I gave a builder, for example, access to the Wi-Fi so that they could listen to music, they wouldn't need access to the printer as well. So we need to start taking that into account. And then there's safety and security as well. Now, I mentioned smart locks in the routine on the previous slide. I don't actually trust them yet. I've seen too many videos on YouTube of people able to hack them, break them open. You send them the right Bluetooth commands or RFID commands, whatever, to get into there. So I haven't actually got them yet, but it is something I'm interested in the future. I need to be able to keep an eye on my home, so some kind of CCTV around the perimeter, not inside because that's too intrusive for me, but around the perimeter would be good. And again, if people want to look at it, they should be able to do it by going to CCTV in a browser, not having to remember that that's actually 192.168.8.2 because it's on a different VLAN. I want to know when things happen around the house. So all of the sensors that feed into Home Assistant are also feeding into Prometheus and Grafana, and there's a built-in Home Assistant plugin for that. And I want to know if there's an issue with the house as well. So if there's a fire alarm goes off, if there's a break-in, that kind of thing. So we need to look at smart alarms of some sort. So that's a kind of overview of where I'm at so far with my home automation. So let's have a look at HashiCorp for a bit quickly, and then we'll come into Stack and how I use HashiCorp in order to manage all of this. So there's a few answers to the question why HashiCorp. But the most straightforward one is actually, it just works. If we look at Consul, Vault, Terraform, if we look at Nomad, Vagrant even, they are all single binary applications. They stand alone in their own right, deploying them is trivial. Getting them to run is very easy. Getting them to run with reduced privileges is also easy. There's a fantastic community support around the products. Quite often, and especially with Consul, though with Vault we're seeing it more and more, what were previously enterprise features are starting to make their way into the open source product, which is fantastic. They're well known throughout the industry. I suspect that if we were all sat in a room together and I asked who uses HashiCorp tools now to put their hands up, it's a HashiCorp conference, it's going to be at least 95%. But I suspect that even if I was at AWS reInvent or something like that, there's going to be a lot of hands go up. And because it's so well known throughout the industry, it means there aren't any new skills for me to learn because I already use these in my day job. And with Consul and Vault and Nomad and Terraform, we've got this DNS-based service discovery, secrets management, container orchestration, and rapid deployment, and they all talk to each other seamlessly. So let's look at this stack and let's see how I've got this configured and what it is I'm doing. So this is a network diagram of what I've currently got. And like all good network diagrams, it needs a bit of updating. However, what we can see is we can see Vault and Nomad and Consul and Trafic. Now, Trafic, for those of you that don't know it, is a reverse proxy, and it plays a very important part in my network. So when a client puts in a request to access something, the first thing it hits is Pi-hole. Pi-hole, for those of you that don't know it, is a DS filter. At the moment, I'm running that on Raspberry Pis. I do plan to run it in containers under Nomad in the near future. And Pi-hole then talk to Consul, and Consul then talk to the upstream DNS servers, which in my case is Cloudflare. And I'll show you some walkthroughs of how the patterns actually work in a bit. But what all this means is that, let's say I wanted to launch a new container for Octoprint, which is a fantastic web interface for running 3D printers. I can write my Nomad file. I can run that against my Nomad server, and it will retrieve API keys from HashiCorp Vault. It will launch the container into Docker with the appropriate configuration file, and it will register the service in Consul. Consul will then perform a health check of Octoprint, and it will say, okay, this service is good to go, at which point Traefik will pick up the configuration, create a Let's Encrypt TLS certificate for it, and my Octoprint install turns up at octoprint.service.mynetwork. And I won't, give away what my network is, but that's where it turns up. By default, the top-level domain for Consul is .consul. So if you don't make any changes to any of your config files or anything like that, then all of your services will turn up at service name.service.consul. So octoprint.service.consul, homeassistant.service.consul, that kind of thing. So purely with 5 tools if we include the Docker daemon underneath, 3 of which are from HashiCorp, we've got a really easy way to launch containers and get DNS-based service discovery. So let's just have a look at how this maps back to those user requirements. For ease of use, Consul provides these easy-to-remember DNS entries instead of IP addresses. I can open up a browser, and I can go to Home Assistant, or I can go to Grafana, or I can go to Octoprint. And I can see my home automation, or I can see my monitoring and logging, or I can see what the status is of my 3D printer, instead of having to remember what the IP address is for each of the containers, or Raspberry Pis, or servers, or whatever else it is that's running. It's easy to manage. If you've not looked at Nomad and the file format that describes a new job for Nomad, then I strongly recommend it. If you know Terraform, it's very easy to pick up. And with Vault, it will pull in passwords. Where this comes in really handy in the enterprise, to skip ahead a bit, is Vault has the ability to automatically rotate database credentials for MySQL, for Postgres, and for a couple of other database engines. And if Vault rotates the credentials for a database, Nomad spots that and restarts the container with the new credentials. So, although it's overkill for my home network, it was really useful when I was previously running an IoT managed service, where Vault would rotate all of the database credentials every 90 days. So I didn't have a clue what they were, because they were all stored in Vault. And Nomad would automatically restart all of the containers across the platform to take account of these new changes. So not only did I not know what the passwords were for the databases, they were constantly changing, but I didn't have to worry about updating the configuration. So if you've not looked into the side of Vault, I'd highly recommend it. The need for an app. So I mentioned earlier on I've got smart light switches. All of this, including the light switches that I'm using, things like that, are documented on a blog that I will give you a link to at the end of it. I don't earn any money off that blog. I have to say, it's purely for me to share the stuff that I'm doing. But smart light switches instead of smart bulbs means no change in user interface for those that aren't necessarily tech savvy or don't want to install the app or can't install the app for whatever reason. As well as Vault for the secrets management, and it can do static secrets as well, of course, and I'm using that to talk to some APIs where they generate the keys for me. I've also got dedicated VLANs for CCTV, another one for my IoT devices. I've got a guest network. And all of these things make sure that the home network is compartmentalized. Now, one of the challenges with that is that it's quite tricky unless you've got a multi-homed server, so a server with multiple Ethernet cards in it. It's quite tricky to assign containers across a VLAN. So what I'm starting to do is I'm actually starting to have the Nomad controller in my management network, and then the Nomad clients, which is how you scale out Nomad, split into the other VLANs so that they can talk back to the central controller, but I can say, and this needs to be launched into the IoT VLAN or into the security VLAN or wherever it needs to be. And again, That's so easy to do. You can do that based on Nomad client attributes. You put a little thing at the top of your file for your Nomad description, and away it goes. It finds the right server that it needs to deploy it, and you can do it based on architecture. You can do it based on the amount of RAM available, the amount of disk space, the type of disk, and any kind of arbitrary tag. So if you were working in AWS with Consul and Nomad and Vault, and obviously AWS have services that will do a lot of this stuff for you, but if you were working with it there, you could actually say, well, actually, I want you to split this so that we have at least one container in each availability zone. Or I want all of these to only exist in US East 2. That kind of thing. And because Nomad, Vault, and Consul also all have Prometheus exporters built into them, it's very, very easy to get the metrics out of them and to display them on a dashboard. As far as content filtering is concerned, I've already touched on Pi-hole. You can filter on categories, you can add whitelists, you can add agents to other things, so I can actually block my Amazon echoes from talking to anything other than the Amazon servers. It completely stops them from working, so don't do that. I found that out the hard way, but it's certainly possible that you can do that kind of thing. And the other thing about the service discovery that I mentioned around DNS is that it makes it really easy to configure database URIs, because I can just say, go to database mysql.service.mydomain, and Consul will automatically route that traffic to the appropriate host. And if a server falls over or something like that, then it can provide almost a round-robin style failover. And as I say, I've got multiple layers of DNS. So the clients talk to Pi-hole that does the initial filtering, Pi-hole talks to Consul that does the local service discovery lookup, and then Consul talks to public DNS, which in my case is Cloudflare for everything else. And then finally you have the secure proxying of services, where Trafic goes off and generates an appropriate TLS certificate based on the tags that I give it in Nomad or Consul. So that's how I've got it set up. And again, there are blog posts. I'll link to my blog at the end, but there are blog posts on all of this, including sample code if people want to go away and play with it. But let's have a look at some of the results now. So let's say I want to do something simple, like turn a light on from the app. So this is what that looks like. And people are going to think some people will think this is overkill. I know some of my family members certainly do. But this is what's going on behind the scenes. So we've got a movement sensor. That picks up a message and sends a message over something called Zigbee, which is a low power radio network, to something called Zigbee to MQTT, which is running via Nomad in a Docker container. That's actually got a pass-through to a physical USB stick that's plugged into the host, so you can do all of that kind of stuff in Nomad as well, which is really valuable. It's the same approach I take for the 3D printers, which we'll look at in a minute. Zigbee to MQTT takes the Zigbee message, converts it into an MQTT message, and shoves it off onto an MQTT queue, which is also running in a container and has appeared at mqtt.service.mydomain. Home Assistant, which runs on Raspberry Pi, I've not quite got to the point of moving that into Nomad yet, mainly because it runs on a dedicated VLAN and I haven't got hardware in there, as I mentioned before, to run the Nomad clients. But Home Assistant then picks up that message and says, okay, so from the movement sensor, I now need to turn a light on. So it sends an MQTT message back to Zigbee to MQTT, and Zigbee to MQTT sends out another Zigbee message to the light switch itself, which then turns the light on. But the nice thing is that all of the containers and Raspberry Pis are registered in Consul, either automatically in the case of MQTT and Zigbee to MQTT via Nomad, or via Consul agent running on the Raspberry Pi. So when I type in Home Assistant, it goes to the Raspberry Pi, and when I type in Zigbee to MQTT, it goes through to the Zigbee to MQTT container. This is one of my favourite automations. When my 3D printer stops printing, the lights in my lounge flash green on and off for a minute. So we slice the file on the laptop, we send it to Octoprint, which is running inside Nomad. Octoprint has again got this USB pass-through through to the physical host, which then goes off to talk to the printer. Home Assistant talks to Octoprint, and then when it realizes that the printer is finished, it sends a message via Zigbee to MQTT to tell it to flash the lights green for a minute. So you can see we've got all these feedback loops, and they're really useful to just make people aware of what's going on. But you could easily set it up so that if the temperature got too hot, it announced on Sonos speakers, for example, that the temperature in a particular room or the humidity in a particular room was too high. One of my favourite automations, and the one that I'm waiting to implement, is if it gets too hot in the kitchen area, then open the roof lights to let the moisture out and the heat out. So once that's up and running, hopefully I'll be able to put a video of that up somewhere as well. So I'm conscious of time, we're 25 minutes in, so let's have a look at how we adapt to this for the enterprise. A lot of the work that we do at Contino, as I said at the beginning, is about encouraging enterprises to adopt the cloud and to undergo digital transformation. And the tools that I'm using at home, one of the reasons I'm using them at home is because I use them at work and have done for many years prior to joining Contino as well. So how do we move this out of our house and into the cloud, or indeed the data center? And that is one thing that I should probably point out. Whilst we are about helping people migrate from data centers to clouds, all of this stuff runs on physical hardware in my house. There is nothing from stopping you running it on physical hardware or VMware or Kubernetes or OpenShift or whatever else it is you're running inside your own data centers. So first of all, it scales really well. I've already mentioned that for Nomad, you can deploy additional Nomad clients to run more containers. It's Docker under the hood, so standard Docker containers work absolutely fine. There is a Nomad client for both ARM and Intel hardware and AMD. So if you want to take advantage of some of the ARM instances inside AWS and run Nomad on those, you can. If you want to run it on a Raspberry Pi, you can. And in the past, I have actually had Raspberry Pis running as Nomad clients. And again, I've just used attributes saying, this container needs to be deployed onto a system that's got an architecture of ARM 6, ARM 7, ARM 64, whatever it is. Consul uses the RAF consensus to provide a highly available service. It's recommended that you run at least 3 Consul nodes, if not 5. Always run an odd number. There's many docs on how to scale out Consul, but that works really well. Vault, the auto-scaling, is built into the enterprise version. You can have active, passive Vault, but doing the replication of the data can be challenging with the open source, but it is possible. And it's really simple to manage. As I said, if you know Terraform, you'll know Nomad. Consul automatically picks up the services from the Nomad integration. Secrets in Vault can be managed via Terraform. They can be retrieved natively inside the containers, which means that no one ever gets to see those passwords. And then Trafic creates certificates from Let's Encrypt on my home network, but quite easily, if you're using HashiCorp Vault for a PKI, also use those certificates to bring the system through. Bring the certificates through, rather. So that's about it from me. If you want to learn more about Contino and how we can help you migrate to the cloud and with your enterprise transformations, then www.contino.io is the place to head, or find us on Twitter at ContinoHQ. We're doing all kinds of fantastic stuff at the moment across AWS, Google Cloud, and Azure, and I'm loving the steps that we're taking around observability at the moment. So keep an eye out for some blog posts around observability and things like that in the future. If you want to get in contact with me, Prof Falcon is my personal Twitter handle. Budget Smart Home UK is my website, so that didn't fit in Twitter. So BGT Smart Home UK is my Twitter handle. And there are blog posts about all of this stuff, including how to choose a home automation hub, the light switches that I'm using, how I've got my stuff set up, links to a GitHub that's got various config files in it, and even sample Grafana dashboards there as well. So that's it from me. Enjoy the rest of the conference. Thank you very much for your time, and hopefully we'll catch up in the real world at some point soon.